Welcome to today's Explainer. We are jumping right in because today we're navigating a massive global crisis, specifically the silent constraint on our energy transition. Look, we're right in the middle of this world-changing shift towards solar panels, wind turbines, and electric vehicles, right? And we all know this transition requires a truly staggering amount of resource extraction. We literally need mountains of copper, lithium, nickel, and rare earths to build this low-carbon future. But as we race to mine these essential materials, we're actually running headfirst into a paradox that could literally stop our clean energy goals dead in their tracks. So let me ask you a question. What exactly is this critical resource bottleneck? I mean, what could completely stall the production of all those new solar panels and EVs we're relying on? Is it a lack of available land? Maybe a shortage of capital? Or a deficit of human engineering? It's water. Okay, let's dive into this. It turns out that the very resources we need to save our climate are incredibly dependent on one of the Earth's most threatened resources. To figure out how this all works, here is our roadmap for today. 1. The green energy blind spot. 2. Mapping the water crisis. 3. How mining impacts water. 4. Risks to the supply chain. 5. Catchment-based water stewardship. And 6. Securing a sustainable future. Section 1. The green energy blind spot, a thirsty industry for a clean future. While minerals and metals are absolutely crucial to a low-carbon economy, pulling them out of the earth is heavily constrained by physical water risks. Basically, mining is incredibly thirsty work. Dr. Emma Gadgen, the director of data and research at the ICMM, hits the nail on the head here. She says, if water risk exposure is not better understood and managed across the wider economy, we risk sleepwalking into a major constraint on the energy transition. That word, sleepwalking, is so powerful. It really emphasizes the sheer scale and, honestly, the hidden danger of ignoring water risks. This isn't some distant future possibility. It's a massive issue right now. Section 2. Mapping the water crisis, analyzing 12,000 global facilities. To truly grasp the size of this blind spot, we have to look at the numbers. The ICMM recently did this incredible, first-of-its-kind, comprehensive analysis. They overlaid point location data from 12,000 mining and metals facilities across 148 countries with global water risk datasets. And the headline statistic? It's just staggering. Nearly two-thirds, 65.7% of all those facilities are exposed to high levels of at least one major physical water hazard. To put that into perspective, the vast majority of our global supply chain is sitting right in the crosshairs of a major water crisis. And this brilliantly illustrates what those specific hazards actually are. The most common threat is baseline water stress, which affects 38.2% of facilities. That basically means there is severe, intense competition for water in highly arid conditions. Then, right behind it is drought at 27%. And the third biggest threat is intra-annual variability at 16.2%. That one is essentially a highly unpredictable roller coaster of a water supply from one year to the next. Now, geography completely dictates the exact nature of this vulnerability. Let's look at Chile, for example. They're the world's top copper supplier and a massive player in lithium. An alarming 85.8% of their facilities face concurrent water stress and variability at the exact same time. Over in Africa and the Middle East, you've got over 80% exposed to high drought risk. In Oceania, 74% are facing severe year-to-year supply fluctuations. And honestly, here is the craziest part. Nearly 5% of facilities globally face compound risk. That means 3 or more of these major hazards are happening to them simultaneously. Section 3. How mining impacts water. The two-way street of water risk. Now, this crisis is very much a two-way street. The mining industry isn't just threatened by the environment, it heavily impacts local catchments too. First off, extractive operations suck up massive volumes of water for processing and cooling, and that puts them in direct competition with local communities and farmers. Second, all that intensive groundwater pumping can severely deplete local aquifers, just tanking the water tables. Third, there is the ever-present risk of effluent and tailings contamination, where heavy metals can find their way into river catchments. And fourth, simply digging massive holes in the earth alters the natural physical flow of water, which makes local erosion and flash flooding so much worse. It is a dirty, thirsty, and highly complex reality on the ground. Section 4. Risks to the supply chain. Bottlenecks in the green transition.
So how does this localized environmental impact actually affect you and the global production of green tech? Well, these water shortages threaten to create massive supply bottlenecks. Look at platinum group elements. 74% of them face drought risk. Key battery components like manganese and copper face compounded weather exposures. When extreme floods or droughts hit, mining simply halts, and that translates to massive production losses, total supply chain chaos, global metal price spikes, and ultimately, a much more expensive, heavily delayed clean energy infrastructure for all of us.
Section 5. Catchment-based water stewardship, shifting the paradigm. So, the crucial point is, how do we fix this systemic issue? The ICMM has proposed a new maturity framework to completely shift the paradigm. The old way of doing things was very reactive. It was just site-level water management, where a facility only worried about the water inside its own fence line. The new way? That's integrated catchment-based water stewardship. Think of a catchment as the entire shared river basin or watershed. This means abandoning isolated management and instead managing water collaboratively alongside local communities, agricultural farmers, and the broader ecosystem. Out in the real world, this stewardship looks like active, on-the-ground environmental monitoring. It's treating water as a shared, deeply precious resource. The whole goal of this ICMM framework is to help companies seamlessly integrate this shared management style right into their broader business agendas. They have to navigate these climate complexities to reliably deliver critical minerals without draining local communities dry in the process. Section 6. Securing a sustainable future. Actionable steps for the industry. So what concrete actionable steps do governments, investors, and companies need to take right now? Well, the data is clear. We have to integrate long-term water risk directly into our energy policies and strategic planning. We need to rapidly scale up closed-loop systems so facilities are constantly recycling their fresh water. We also need to get creative and utilize alternative sources. For example, Chile's already piping in direct ocean water for some operations. Governments absolutely must establish clear, strict environmental flow thresholds before issuing new mining concessions. And, of course, we need total public reporting and facility-level data transparency. To secure our critical minerals, we have to completely move away from the old, linear model of withdrawal and discharge. So I want to leave you with this final, provocative thought. Will we integrate water security into our energy policies in time? Or will a thirsty supply chain just dry up our clean energy goals? It's a monumental challenge, but one we absolutely must meet. If you found this update helpful, please hit the like button and share this video with fellow members. For more deep dives into the latest environmental regulations and industrial news, subscribe to our channel and turn on notifications. See you in the next one.